Good morning, my people. Today we are going to go through the Unit 6 study guide, Introduction to Polynomials. Unit 6 is one of the units that you can PIP between now and April 14th. So if you've been thinking you might want to PIP this test, what I would do if I were you is go over to my website, print out the a new copy of the Polynomial Study Guide. Or if you don't have a printer, just grab some paper and you can solve the problems with me as I go along. And make sure that you understand how to do everything before you attempt the PIP, okay? We're going to start with the algebra tile problem. So one of the things that you needed to be able to do was to represent algebraic expressions with algebra tiles and translate algebra tiles. So it's very important that you pay attention to the key. Excuse me. You see that the white bar represents x, the white square represents 1, the black bar represents negative x, and the black square represents negative 1. So if we make algebraic expressions for number 1, you see that you have 3 white bars. So that's x, x, and x. That would be 3x. You have 4 black squares, negative 1, negative 1, negative 1, negative 1. That would be minus 4. 3x minus 4 is how you would represent that particular expression. For number 2, what they want you to do is you don't necessarily have to simplify unless it says, okay? So for here, you have 5 white bars. That's 5x. Here you have 1 black bar, so that's minus 1x. Then you have 4 white squares, that's plus 4. And you have 1 black square, which is minus 1. Now you need to pay attention to the directions to see if they want you to simplify. This would be your answer for here. If it did say simplify, then you would combine your like terms and you'd get 4x plus 3. Okay, so it just depends on the directions. Make sure you're paying attention. Number 3 says to draw the tile model that shows 2x minus 3 times x plus 2. So remember that when we multiply, we use the box method. So in order to draw the tile method to show multiplication, we draw our box. So 2x minus 3 would look like this. Here's 2x minus 1 minus 2 minus 3. And then x plus 2 on the other side, okay? In order to multiply, what you do is you draw horizontal lines across where the bars and the boxes meet, and you draw vertical lines down where the bars and the boxes meet. And then you fill in all the pieces in the middle with what they are. So if this is x, x, negative 1, negative 1, negative 1, this is x, this is positive 1, positive 1. X times x is x squared. X times x is x squared. X times negative 1 is negative x. Same for this and same for this. X times 1 is positive x. Same for that. Same for this, same for this. And all 6 of these squares here are going to be negative 1 because you have a positive 1 times negative 1. Positive 1 times negative 1. Positive 1 times negative 1. All right. Okay, draw the tile model. Then it says write the simplified answer. So what we're going to do is we're going to combine our like terms. I have 2x squareds. I have 4 positive x's. I have 3 negative x's. And I have 6 negative 1's. Then combine my like terms. 4x minus 3x is 1x. And there you go. Okay? Let's roll on to the next page. Write the problem represented below. So I have 2x squared plus 3x plus 1 plus negative x squared plus 2x minus 3. Notice that I put each polynomial in parentheses because the plus here and the plus here is separate from this plus. And the plus here and the minus here are separate from this. So you want to notate that you're doing this whole thing plus this whole thing, okay? What is the sum of the polynomials? Now, when you're adding polynomials, okay, you can basically rewrite the whole expression without the parentheses and combine like terms because the plus is not going to change any signs. So I'm going to take what I see here and rewrite it down here without parentheses. 2x squared plus 3x plus 1 minus x squared plus 2x minus 3. And if I combine my like terms, 2x squared minus 1x squared is x squared. 3x plus 2x is 5x. And positive 1 minus 3 is negative 2. This is your simplified answer, which you would put here. That little line is a little bit too small for me. Okay. For number 5, draw a model to show the sum of negative 3x squared plus 5x minus 3 and 2x squared minus 2x plus 3. So if we're doing sum, that means it's going to be plus. So negative 3x squared, I'll need 3 of these, plus 5x minus 3. All right. And if I'm doing the sum, I would put a plus sign right here. And now 2x squared minus 2x plus 3. All right, there would be the model. Now, to do the sum, I could rewrite, as I said, the whole thing just without the parentheses. So negative 3x squared plus 5x minus 3 plus 2x squared minus 2x plus 3. Negative 3x squared plus 2x squared is negative 1x squared. 5x minus 2x is 3x. And negative 3 plus 3 is 0. So this would be your final sum. All right, for the next one, write the problem represented below. Let me erase some of this stuff that I just wrote so I have space to write on that line. I see here that I have a difference, okay? So don't forget, we're going to put all this in parentheses and we're going to put all this in parentheses. So I have negative 3x squared plus 2x minus 3 minus negative 2x squared plus 3x plus 2. Okay. Now it says, what is the difference of the polynomials? Now we have to be careful with difference. Remember that, let me change colors here. Remember that when you have a minus sign in front of parentheses, you are really distributing a negative 1. All right, you remember this back from equation solving. So we can't just recopy everything without the parentheses. We have to actually make sure we distribute. In the second polynomial, we have to distribute a negative 1. So we would keep the negative 3x squared plus 2x minus 3. But then negative 1 times negative 2x becomes positive 2x squared. And negative 1 times 3x becomes negative 3x. And negative 1 times 2 becomes negative 2. You have to remember you're not just subtracting the first thing, you're subtracting all of it. So minus a negative becomes a positive, minus a negative becomes a positive, minus a positive becomes a negative, okay? All of those signs are going to change. Once you do that, then you can combine your like terms. Negative 3x squared and 2x squared is negative x squared. 2x minus 3x is negative x. And negative 3 minus 2 is negative 5. This would be your simplified answer, the difference of the polynomials. Be very, 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 very careful with this situation, okay? Let's go down to number 7 and 8. Write an addition problem where the answer is, write a subtraction problem where the answer is. There are so many possible ways to do that. I'm not going to bother with that right now. Let's go to our perimeter and area problems. Okay. What is the perimeter of the rectangle in terms of x? So first of all, what does perimeter mean? The distance around. So it's all 4 sides. You could say 3x squared plus 8 plus another 3x squared plus 8 plus x plus 3 plus another x plus 3. Or you could multiply each of them by 2. 2 of these plus 2 of these will equal the perimeter, whatever that is. All right. We don't know. We don't have an answer for the perimeter. We're just writing an expression for the perimeter. So 2 times 3x squared plus 8 plus 2 times x plus 3. That's going to give me all 4 sides. And now I'm just basically simplifying. Distributive property, 6x squared plus 16 plus 2x plus 6. I have 1x squared. I have 1x, but I have 2 constants. So that was going to become 22. And that is answer A. All right, for the 2 through 5 here, we're going to simplify. So let's see what we can do here. Notice that I have subtraction here. So when I rewrite this, negative 7x to the 9th plus 12x to the 6th minus 12, I am distributing a negative 1 to all 3 of these terms. So minus 5x to the 9th minus 4x to the 6th plus 9. Now I can combine my like terms. That's going to be negative 12x to the 9th. I've got x to the 6th, 12 and 4, 12 minus 4, so plus 8x to the 6th. And negative 12 plus 9 would be minus 3. For number 3, let me change colors. These are all going to run together here in a minute. I have another minus, so I'm going to be distributing negative 1 here. So I have 8x to the 3rd minus 6x plus 10 minus x to the 3rd minus 10x squared plus 9. So 8x to the 3rd minus x to the 3rd is 7x to the 3rd. Negative 6x, wait a second, I have a 10x squared, but I only have 1x squared, so I'm going to keep it. I only have 1x, the negative 6x, so I'm going to keep that. But I have 10 plus 9, so that's going to give me 19. Okay. Change colors again. I'll go to pink this time. I have another minus here, so I'm going to be subtracting. So 6x squared plus 4x plus 1 minus 4x minus 20. I only have one x squared term, so I'm going to keep it. I have 2 x's, and they just happen to be a 0 pair. And I have 2 constants, and that makes minus 19. And my last one, again, I have a negative, so that's going to be a 1 in the front. We're going to distribute. So this is 5x minus 3x plus 2. And 5x minus 3x is 2x. 2x plus 2 is the final answer. All right? Just be ultra careful with that negative in front of parentheses. You've seen that before. You've done that before. We've solved equations, about 1,000,000 equations with a negative sign in front of parentheses. You know what to do. You just have to recognize it here as well. All right, number 6 says consider the following model, and you can see that we have x squared, x and 1, negative x squared, negative x and negative 1. Which polynomial is represented by the following? Well, the square box is an x squared. Whoops. The 4 colored bars are negative x's. The 3 colored squares are negative 1's. Plus, I've got 2x squared, 3x minus 2. All right, so since it's plus, I can rewrite it without the parentheses, and I can just rewrite it how it is. And simplify. So x squared plus 2x squared would be 3x squared. Negative 4x plus 3x would be negative x. And negative 3 minus 2 would be negative 5. And it looks like our answer is A. All right, now moving on to the good part. All right. Number 7, give two trinomials so that the addition of the two trinomials is 2x plus 5. So we need something that will add up to 2x. I'll say x and x. And I need two things that will add up to negative 5. I'll say negative 7 and positive 2. There you go. There are a million different answers for this one that you could have done. Going to number 8, we're going to find the perimeter of each figure. So this is very similar to that problem we just did on the other page with the rectangle. Let me make this a little bit bigger so that when I write, I won't take up the whole page. I need 2 of this side, and I need 2 of this side. So if I have 2y squared minus 3 plus 2y squared plus 2y minus 4, because I'm adding. Distributive property, 2y squared minus 6. Distributive property here, 2y squared plus 4y minus 8. Combine your like terms, 2y squared and 2y squared is 4y squared. I have one y term right here, and negative 6 minus 8 is negative 14. This is your perimeter for here. For problem B, find some, I think I'll do my space right there. I'm going to switch colors too in case it runs into another one. We'll go with turquoise. So for a triangle, you just add up all 3 sides. So it's going to be this plus this plus this. And I'm just going to write it all straight across. X squared minus 6x plus 4 plus x squared minus 6x plus 4 plus x squared minus 7x plus 13. Now, if you were paying attention, you would notice that these two sides are both the same. So instead of writing them separately, you could have said 2 of these plus that. Okay, either way is going to work. X squared plus x squared plus x squared is 3x squared. Negative 6x minus 6x, that's negative 12x. Minus 7x is minus 19x. And 4 plus 4 is 8. Plus 13 is what, 21? So there is the perimeter of the triangle. All right, rectangle C. Let's go for purple. I need 2 of these, and I need 2 of these, because I have 2 lengths and 2 widths. So 2 times 2x squared plus 2 times 5x squared minus 6. Distributive property, well, this is just multiplication, 4x squared, but I do have distributive property here, 10x squared minus 12. 4x squared plus 10x squared is 14x squared minus 12 is the answer. And D, we have another triangle, and I'm looking and I see that our triangle, our sides are all 3 different, so we're going to have to do them separately. So I'll just add them up. 3y squared plus 4y squared plus 6y squared minus 2. So I've got 3y squared. 3 plus 4 is 7, plus 6 is 13, minus 2. That's it. Okay. Those were not too bad. Doing this is going to lead us into something coming up later on. Now we're multiplying polynomials, all right, multiplying. Which expression is equivalent to 5x minus 2y times 4x minus y? Okay, so remember that when you multiply polynomials, you use the box method. Except for this time, instead of drawing the tiles, we're going to actually use the numbers we're given. So 5x minus 2y, 4x minus y. And you just multiply like it's a multiplication table. 4 times 5 is 20. X times x is x squared. 4 times negative 2 is negative 8. X times y is xy. 5 times, this would be negative 1, is negative 5. X times y is xy. Negative 1 times negative 2 is positive 2. And y times y is y squared. And then when it comes time to simplify, remember that I told you guys that your like terms should always be on a diagonal like this. So you see negative 8xy and negative 5xy, those are like terms, but you only have one x squared and you only have one y squared. So what you would do, let me get a color a little bit darker, is we would say, okay, we have 20x squared. I have negative 8 minus 5 is negative 13. And then plus 2y squared. And let's see which one is equal to that. It looks like it is A. There you go. All right. Now number 2 is talking about the area of a rectangle, and it even tells you its length times width. Find the area of the rectangle that has a length of x plus 3 and a width of negative 2x plus 1. So basically you are multiplying these two binomials, and we will again use our box. So x plus 3, 2x minus 1. 2x times x is 2x squared. 2x times 3 is 6x. X times negative 1 is negative x, and negative 1 times 3 is negative 3. Here are your like terms. So you have 2x squared plus 5x minus 3. And this is your answer. Okay. Now, number 3 is a fun one. Find the expression for the area of the shaded region. If I want to find the area of the shaded region, then what I should do is I should find the area of the whole rectangle, the whole large rectangle, which is going to be x times 9, or x plus 9 rather, times x plus 6. Then what I want to do is I want to subtract the square, the white square in the center. And by doing that, that leaves me with the shaded area. Well, so I need to subtract x times x plus 4. Okay, that's how you do the shaded area. Now, what I want to do is I want to simplify this and simplify this. I'm not going to touch the subtraction just yet. So let me do x plus 9 times x plus 6. I'm going to let's see, I'm going to do it down here. X plus 9, x plus 6, this would be x squared, 9x, 6x, 54. Here's my like terms, so x squared plus 15x plus 54. All right, let me put that back up here. X squared plus 15x plus 54. I'm going to keep it because I'm not touching the subtraction yet. And now for the x times x plus 4, I'm just going to distribute. X times x is x squared, and x times 4 is 4x. All right, now it's time for me to do the subtraction, which is really, remember, a negative 1 that you need to distribute. So I'm going to keep the trinomial at the beginning, and I'm going to distribute this negative 1. Negative 1 times x squared is negative x squared, and negative 1 times 4x is negative 4x. Now I can combine like terms. X squared minus x squared is 0. That's a 0 pair. 15x minus 4x is 11x, and plus 54 would be my remaining. that is the expression that represents the shaded area. You guys should have done shaded area in 7th extended last year. It's always basically, if you can't remember, if this is just like, you're like, Ms. Bryant, you lost me. It's always the area of the outside shape minus the area of the inside shape. And when it's rectangles, it's length times width times minus length times width. Okay, if you have a different shape, then you have to use a different area formula. So we're going to write an expression to represent the area of each figure. Let me get a different color. I'm going to go with pink. All right. This is a rectangle, and the area of a rectangle is length times width. So I'm just going to do that times that. So the expression is going to be 2x plus 5 times 4x minus 1. Now, I do need to find out what that is simplified. So I'm going to come over here and do the box. 2x plus 5, 4x minus 1. So this would be 8x squared, 20x, negative 2x, negative 5. Here are your like terms. So we have 8x squared plus 18x minus 5. That is the answer for this one. All right, now for a circle, it's a little bit different. The area of a circle is pi r squared. So pi times the radius squared. Now, remember r is radius. Radius goes from the center of the circle to the edge. 2x plus 4, they're showing me, is going all the way across, which is the diameter. To find the radius, you cut the diameter in half. So let's think about this. What's half of 2x? 1x. What's half of 4? 2. Now, I have to square that. Now, I've been seeing a lot of misconceptions with expressions like a binomial squared. A lot of people are writing things like, okay, x plus 2 squared equals x squared plus 4. They're squaring the x and squaring the 2. That does not work when you're adding, okay? That works when you're multiplying. You can just square each term. But when you're adding, x plus 2 squared really means x plus 2 times x plus 2. It means, you know, to square a number, to square an expression means to multiply it times itself. So this would be the expanded form, okay? And then if you're going to do this, you're going to have to do the box. X plus 2, x plus 2, x squared, 2x, 2x, 4. This is the part right here that was missing if you just say it's x squared plus 4. You're missing the middle term. You're missing the b term. So you got to be very, very, very careful when you see something like this, where you're squaring a binomial. You have to do it like this and use the box method. You don't just square the two terms. I would say I've been seeing maybe, I don't know, 3 or 4 people maybe doing that. So we got to be extra super careful. Now let's talk about the triangle. The triangle has a different area formula altogether. I'm going to change colors. I'm going to go back to blue. The area of a triangle is 1/2 base times height. And the base and the height in any triangle always form a right angle. So it doesn't matter which way the triangle is oriented. Wherever the two pieces are that make the right angle, those are the base and the height. So if this triangle had a right angle, it would be right here. So the way that we're going to write this is 1/2 the base, x squared minus 2x plus 6 times the height, x plus 4. Now, some of you guys might be panicking about the 1/2 right here. I'm going to ignore that until the very end. I'm going to go ahead and do this multiplication first, okay? So we're going to use the box method. So let me come over here where I have some space. And this box is going to have a trinomial and a binomial. So we're going to have x squared negative 2x 6, x, and 4. So x times x squared is x to the third. X times negative 2x is negative 2x squared. X times 6 is 6x. 4 times x squared, 4x squared. 4 times negative 2x, negative 8x. And 4 times 6, 24. You have two sets of like terms here and here. So if we simplify, I'm going to come over here. I've got my 1/2 still, and then I have x to the third. 4x squared minus 2x squared is 2x squared. And negative 8x plus 6x is negative 2x and 24. Okay. Now let's deal with the 1/3. Let's just distribute. Now, 1/3 of 1, we don't, or I'm sorry, 1/2 of 1, we don't have any choice but to just write it like this. But 1/2 of 2 is 1. 1/2 of 2 is 1. And 1/2 of 24 is 12. Here would be your final answer. All right. And then we go to problem D. Problem D is only giving us one side. I'm going to assume then that this is a square because otherwise I can't do the problem. If it's a rectangle, I don't know what the length is. So we're just going to assume that it is a square, which means the area of a square is side squared. So 2x minus 3 squared. So remember, you have to expand this. You cannot just put 4x plus 9, okay? You have to expand it. When you expand it, then you can multiply with the box method. We have 4x squared, negative 6x, negative 6x, and 9. Here are your like terms. So 4x squared minus 12x plus 9. And there's your expression, okay? Alrighty. Now we get down to some mixed practice. Check all expressions that are equivalent to 2x squared minus 5x minus 12. So for these, you would have to work out all 5 of these. I can do it if you'd like. I don't really have a lot of space on here. I think I'll just check off the ones that are correct, and then you can, if you wanted to see one worked out, you can, I don't know, ask me later. This one would be 2x squared plus 5x minus 12. It would be plus 5x, so that's not, it's not this one. This would be 2x squared minus 5x minus 12. This one is good. This one would be 2x squared minus 5x minus 12. This one's good. This one would be 6x squared, so no good there. This one would also be 6x squared, so no good there. It's just these two. Okay? All right, we're going to simplify this expression. So taking a look at it, what I'm going to have to do first is distributive property. So I have, and notice that I have plus here in the middle. If I had, well, I guess if I had minus, it wouldn't matter because I would be distributing the negative already. So I'm not going to bother with parentheses. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 4 plus 12. 5 times 8 is 40. 5 times 2x squared, 10x squared. Combine your like terms. We have no x's. Huh. All right, 7x squared plus 52 looks like C is our answer. All right, so that was all the adding, subtracting, and multiplying polynomials. Adding, subtracting, and multiplying. The two things I think that I saw the most errors on were the parentheses minus parentheses, where people were forgetting to distribute -1, and when you had something squared, people were not expanding the notation and then multiplying. All right, so those are the two things to watch out for that section. Now, the last section that's on here is dividing polynomials with a monomial divisor. And remember, what that really means is basically we rewrite the problem. You have 3 terms in the numerator, 1 term in the denominator. That means all 3 numerator terms will get divided by the same denominator. So the first thing I like to do is split my division, which basically means write it all separately. Okay, and then at this point I can simplify. So 3 divided by 3 is 1. X to the 4th divided by x to the 3rd. Remember what that means is when you're dividing variables, you subtract the exponent. So x to the 4th divided by x to the 3rd is just x. It's x to the 1st power. All right, plus 9 divided by 3 is 3. X to the 5th divided by x to the 3rd is x squared, because 5 minus 3 is 2. And 12 divided by 3 is 4. X to the 3rd divided by x to the 3rd would be x to the 0. And remember, anything to the 0 power is 1. So just 4 times 1 is 4. This is your answer, except we probably should rearrange it into standard form. They may ask you to do that. All right, second one, let me change colors. I want green, and I want this a little bit bigger. All right, first thing I'm going to do is split my division. When you do this, copy very carefully. Xy to the 5th, 3x squared y squared. 9x to the 3rd y squared. Now some of you may be able to do this without this step, but if you think that you might be at all confused, I would go ahead and do this step. All right, so 27 divided by 3 is 9. X divided by x squared is x to the negative 1. Remember that x to the 1st minus 2 would be negative 1. Y to the 5th divided by y squared is y to the 3rd. We know now, because we've been past the beginning of Unit 9, we know now what to do with negative exponents, but I always wait until the end. I always wait and deal with those after it's the very last thing I do. 9 divided by 3 is 3, and I'm using this negative here. X to the 3rd divided by x squared is x. Y squared divided by y squared is just 1, so nothing goes there. And then 12 divided by 3 is 4. X cubed divided by x squared is x, and y cubed divided by y squared is y. Now at this point, I would say, okay, I can't have this. So remember what you do when you have a negative exponent is you move just the piece with the negative exponent to the denominator. So 9y to the 3rd stays in the numerator, and then x to the 1st, which is just x, goes in the denominator. These other terms are fine how they are. So that is what that would look like. All right, and then this one is just written kind of funny. It's written division here, but I'm going to take the 3x to the 6th and just put it underneath all of these. And then get rid of that, okay? So, 27 divided by 3 is 9. Let's see if I can have space to put it down here. X to the 12th divided by x to the 6th is x to the 6th. Keep this plus. 33 divided by 3 is 11. X to the 9th divided by x to the 6th is x to the 3rd. Keep the subtraction. 36 divided by 3 is 12. X to the 15th divided by x to the 6th is x to the 9th. Keep this plus. 3 divided by 3 is 1. X to the 6th divided by x to the 6th is also 1. So I just have to put a 1 there. Keep the minus sign. 12 divided by 3 is 4. X to the 7th divided by x to the 6th is x to the 1st power. When you're adding and subtracting, you have 1, 2, 3, 4, 5 terms. So you have to have 5 terms in your answer. That's why you need the placeholder of 1 here, 3x to the 6, 3x to the 6 is really 1. You need that placeholder, so you can't just not put that answer. You have to put the answer of 1. At this point, I don't see any like terms, but I would rearrange the answer to be in standard form. So I would put the highest variable, negative 12x to the 9th, plus the next highest, 9x to the 6th, plus 11x to the 3rd, minus 4x, plus 1. Okay, whoops, that's not what I want. Okay. And then we have a number 4. So we've got a word problem here. If the area of a rectangle is 16a to the 3rd minus 12a squared plus 8a, and the width is 4a, find the length. Now, this is in the division section, so we know we're going to be using division to solve this problem. So let's think for a second. If area equals length times width, if I want to find the length, if I were going to solve this equation for L, I would divide by W, and L equals A divided by W. So I can use that information in this problem. Here's the area, here's the width. So if I just do A divided by W, I'll have my length. So area, 16a to the 3rd minus 12a squared plus 8a divided by 4a. I'm going to separate it. And I'm going to simplify. 16 divided by 4 is 4. A to the 3rd divided by a is a squared. 12 divided by 4 is 3. A squared divided by a is a. 8 divided by 4 is 2. And a divided by a is 1. So really 2 times 1 is 2. So 4a squared minus 3a plus 2. This would be the expression for the length. Okay, whoops. All right. Now, I've noticed that there was one thing on the study guide or one thing missing rather from the study guide that was on your test, and that was factoring, greatest common factor. So I'm going to erase all this so I can have this space. This is a PDF, so I can't just add another page to the end of this, or if I can, I don't know how. So I'm going to do some GCF problems here, and you should do those along with me. Let's go to black. Okay. So factoring, whoops, here we go. All right, and so this is when we had like, let's see, here's an example. 2x squared y minus 2xy squared plus 4xy. All right, I want to find the greatest common factor, the largest number that can come out of all 3 of those terms, and the largest variable that I could pull out of all 3 of those terms. When I look at my coefficients, I have 2, 2, and 4. So the biggest thing that I can pull out of all 3 is 2. Because I can take 2 out of 2, and I can take 2 out of this 2, and I can take 2 out of 4. So what you do is you actually look for the smallest thing that they all have in common, I guess, is what you're thinking about. For my x's, I have x squared, x, and x. The smallest one is x. And for the y's, I have y, y squared, and y. The smallest one is y. That's the greatest common factor for the whole expression. Now what I have to do is decide, when I factor that out, what would I multiply it by in order to get back to the original problem? 2xy, what would I multiply that y by in order to get 2x squared y? The 2's already there, the y's already there, but I'm missing an x. I have 1, I need 2. All right, minus, look at the second term. I have the 2, I have the x, I have 1 y, but I need 2 y's. So I got to put a y there. Now, 2, this is a 4. So 2 times what would make 4? 2. I have the x, I have the y already. So that's it. Okay, that is how you factor greatest common factor. Okay, so if you want to know if you're right, what you would do is you would just multiply this back and see if you get the original answer. 2 times x times y, or 2xy times x, is 2x squared y. 2xy times negative y is negative 2xy squared. And 2xy times 2 is 4xy. And you would look and see that it's the same thing. Okay, factoring the greatest common factor. Let me give you another one. 14 gh squared plus 28gh plus 14h. All right, so look at your coefficients. What's the smallest coefficient that they all have in common? 14. All right, look at your g's. I have g, but I do not have a g here, so I cannot factor out a g. Not if all of them don't have a g, I can't factor out a g. Let me look at h's. I have h squared, h, and h. The smallest one is h, so I can factor that out. Now, ask yourself, what do I have to multiply this times in order to get that? I have the 14, I have one of the h's, I'm missing the g, so I need g and another h. To get 14 to 28, I have to times it by 2. I have the h already, but I don't have the g, so I need the g. 14 to 14 would just be 1. I have the h, so this is just 1. Multiply it times 1. Okay, here's what I need you guys to do. Look in your notebook, pages 43 and 44. If you don't have your notebook, go on my website, go to PKMS website, go to Departments, 8th grade math, Bryant. Look over to the left and you'll see a link for notebook pages. You can pull up all the notebook pages for Unit 6 and you'll see pages 43 and 44. If I were you, I would go read through the left side, read through page 43 at the directions for how to do the factoring, and then get a clean sheet of paper and write down the problems, say maybe 5 or 10 problems from page 44. The easier ones are at the top, the harder ones at the bottom. So do a mix, solve those problems, and then pull my notebook page up again and check your answers. You need practice on this before you do this PIP, okay? And that is everything for Unit 6. All the polynomials, adding, subtracting, multiplying, and dividing, basically polynomials, all right? If you have questions, pop me an email and I'll do my best to answer it. If you need more of a tutorial for something, again, send me an email and I'll make you another video with more practice, all right? Talk to you later.